In this video, we will learn how to do a hypothesis test for a quantitative variable according to a qualitative variable in SPSS when we have paired data. Then we are in this part of the table. If we read the exercise 3, the qualitative variable is the time and the quantitative variable is the cholesterol level. In that case, we have paired data because the first observation of both samples belongs to the same person. The first thing that we have to do is to prove the normality. When we have paired data, we have to prove the normality of the difference between both variables. Therefore, firstly, we have to create the difference variable. Then we go to SPSS, in transform, in compute variables. In target variable, I put the name of the new variable. In that case, I put cholesterol diff, and in the numeric expression I put the difference. In that case, cholesterol at the end of the study minus cholesterol at the beginning of the study, and finally OK. In the dataset windows, I observe that the last column is the new variable cholesterol diff. Then I am able to prove the normality as we did before. In Analyze, then in Descriptive Statistics, and Explore. Independently, I put the new variable cholesterol diff. In that case, it's not needed to put a factor list because we don't have a qualitative variable, because in this variable contains both variables, cholesterol at the end of the study and cholesterol at the beginning of the study. Yeah. Then we have to go on plots and select the normality plots with test in order to prove the normality, and then continue and OK. We can observe that the results windows is open, and as in the before example, we have more than 50 observations. Then the most suitable test is Kolmogorov-Smirnov. In order to prove the normality, we get a p-value equal to 0.2. Therefore, we have enough evidences to don't reject the null hypothesis. Therefore, we can assume normality. Once we have assumed normality, the most suitable test in order to compare the average level according to time is the t-test for paired data. In SPSS, we have to go in Analyze, then in Descriptive Statistics, Explore, in Analyze, compare means, per sample t-test. In variable 1, we have to put the cholesterol at the end of the study, in that case cholesterol 1, and in variable 2, we have to put cholesterol at the beginning of the study. These are the variables that we want to compare. And finally, OK. At the end of the outputs, we can observe a table referred to t-test. We can observe the mean of the difference between cholesterol level at the end and beginning of the study. Also, its confidence interval here. We can observe the difference between cholesterol level at the end of the study and the beginning is almost 13. And the most important, the p-value here. In that case, is smaller than 0.05 or alpha. Therefore, we have enough evidences to reject null hypothesis. Then there are differences between the cholesterol level at the beginning of the study and at the end of the study. Therefore, there are differences in the cholesterol level after 10 years because its p-value is smaller than 0.05 or alpha. In that example, we use the t-test in order to compare the means because our quantitative variable follow a normal distribution. Unless we have enough evidences to assume normality, then we have to use non-parametric tests, as we did in the last video. If we take a look in the table, this table, we observe that the most suitable test in that case is Wilcoxon. Related samples, non-normality, Wilcoxon. Then we go to SPSS window, database window, and then we go to analyze non-parametric test because now we are doing a non-parametric test, legacy dialogues, and two related samples. As we did in t-test, in variable 1 here, I put the cholesterol at the end of the study, cholesterol 1, and in variable 2, I put the cholesterol level at the beginning of the study, cholesterol 0. In test type, I have to select the Wilcoxon test, in that case is selected, Wilcoxon, and then OK. In that case, we also observe a p-value smaller than 0.05 or alpha. Therefore, we have enough evidences to reject the null hypothesis. Therefore, we observe differences between cholesterol at the end of the study and cholesterol at the beginning of the study.